So we had a couple of questions. We're looking at page 256. Start out with number 5. So for number 5, a force of 760 tons. Parentheses, it says short tons. Now remember we said in this class when you hear tons, it's always going to be 2,000 pounds. So 760 tons times 1 ton is 2,000 pounds. Is exerted on the base of a steel support column. The base has a cross-sectional area of 160 square inches. How many pounds of force are exerted per square inch? So we're going to convert this into pounds. So it's 1,520,000 pounds. Now to get pounds per square inch, you're just taking 1,520 pounds divided by your square inches of 160. So 9,500 pounds per square inch, PSI. Now that's one thing actually where you can, when you look at the units, I mean I wrote it out as PSI, but it's pounds per square inch. And it doesn't necessarily give those units in the problem, but it does ask how many pounds of force are exerted per square inch. So if you can pick out that unit of your answer is going to be pounds per square inch, that tells you that somewhere in your problem you're going to take pounds and divide it by square inches. So you can use those units to help you figure out what to do with the numbers a little bit. Number 7, cubic foot of water weighs 62.42 pounds. That's per cubic foot. At 40 degrees Fahrenheit. 61.21 pounds. This is at 40 degrees. And 61.21 pounds at 120 degrees Fahrenheit. As you heat it up, it expands and it gets less dense. So it takes up more space, or the weight that can be held within a certain space gets to be less. Over this temperature change, what is the average decrease in weight in ounces per cubic foot per degree? So if we subtract these two numbers, 62.42 pounds minus 61.21. It's 1.21, and technically these are both pounds per cubic foot. They want ounces per cubic foot per degree. So I have to convert that into ounces. One pound is 16 ounces. So it's going to be 1.21 times 16. So 19.36 ounces per cubic foot is the change. And now we have to do that per degree. Well, from 40 degrees to 120 degrees, we have a change of 80 degrees Fahrenheit. So we are going to take our 19.36 ounces per cubic foot divided by 80 degrees Fahrenheit. This 0.242 ounces per cubic foot per degree Fahrenheit. Any questions? start off today, I'm going to throw out a problem for you. I think we discussed this one before. So we're going to go the opposite direction. I'm going to tell you that I can throw a ball at a rate of 30 meters per second. I think last time we talked about, did I use 90 feet per second? Did we do that one in here? No? Don't know? All right, let's do that one first then. We'll come back to the 30 meters per second. I tell you, I can throw a ball at the rate of 90 feet per second. Would you believe me? Yeah? Well, is that fast? And 90 feet per second, is that fast? Not really. I'd be in a baseball field, I'd be standing at first base and throwing it home and getting it there in 1 second. Seems kind of fast. What are we used to seeing speed in? Miles per hour. So let's convert that into miles per hour.
What are we handling in this section?
What's that?
What is this section we're going on?
This is compound units. So we're going to do 90 feet per 1 second. 90 feet per second is the same as saying 90 feet over 1 second. Now I have to convert both feet into miles and seconds into hours. So I'm going to do the feet first. I'm going to put feet down here. 1 mile goes on top. That is 5,280 feet. So you can see now the feet have canceled out. Now I have miles on top, seconds on bottom. Right now it would be miles per second. So now I got to get rid of seconds. Now since seconds are on bottom, I'm going to put them on top here. Do I have a relationship between seconds and hours? I could figure it out, but let's just do minutes to seconds. 1 minute, 60 seconds. So I've got rid of the seconds, and right now I'd be in miles per minute. So I go one more step. I got to get rid of those minutes. They're on the bottom right now, so I'm going to put minutes on top. 1 hour is 60 minutes. So now I have canceled out the minutes. I should be in miles per hour. So on top, I've got 90 times 1 times 60 times 60. Oh, what is that? 324,000. My only units up there is miles. On bottom, I've got 1 times 5280 times 1 times 1 hour. So it's 5,280 hours. And then I just have to divide that out. 324,000 divided by 5,280. What, 61.36 miles per hour. Now, do you think I can throw that fast? On a good day, if I warm up, probably only throw about 4 or 5 pitches that fast. But so you can see here the power of doing our conversions using this conversion factor is we can do multiple conversion factors if we have to. So we can change both units in a compound unit like this if we need to, or just one of them if we want to. Let's say that you are told that you have a building and the weight on the floor is 0.8 pounds per square inch. Well, 0.8 pounds per square inch doesn't tell you a whole lot. We're used to seeing floor loading as pounds per square foot. Most of the time you see a floor loaded is anywhere from 50 to 120 pounds per square foot. So we'll set this up again. Pounds per square inch, 0.8 pounds per square inch to be more specific, is 0.8 pounds over 1 square inch. Now, do I have to change the pounds? No, the pounds are staying the same. All I have to change is square inches into square feet. So I have to get rid of my square inches. To get rid of them, where am I going to put them in my conversion factor? Right now they're on bottom, so I got to put them on top so they cross cancel. So I'm changing it to square feet, so that must go on bottom. What's my relationship between square feet and square inches? 1 square foot is 144. Good. Because it's squared, it's 12 by 12, which is 144. So now we have 0.8 times 144. 115.2 pounds per square foot. Any questions on that? You might have a pump that is rated as pumping 12 cubic inches per second. I need to convert that over CFM. What's CFM stand for? Yes, that is cubic feet per minute. So I start out 12 cubic inches over 1 second. I do have to change both units this time. Which one do you want to change first?
Do the seconds first.
Let's do the seconds first. Okay, put the seconds on top. Because they're on bottom here, so we're going to put them on top. What's going to go on bottom? Minute, yes. So 1 minute, 60 seconds. Seconds are gone. We're now in cubic inches per minute, but we want to be cubic feet per minute. So now we have to get rid of the cubic inches. So they're going to go on bottom because they're on top here. Cubic feet. 1 cubic foot is cubes. So do 12 by 12 by 12. So 1728. There you go. So cubic inches are gone. Now we have cubic feet on top and minutes on bottom. That's what we want. So 12 times 60 is 720 cubic feet. And on bottom we got 1,728 minutes. So we got to divide that out. 720 divided by 1728. 0.4167 cubic feet per minute. 12 cubic inches per second. Sounds like a lot of water, doesn't it? Because we're supposed to think a second in such a short period of time. Standard pump rate for a pump, though, in cubic feet per minute. I mean, a really, really small one's like 6 CFM. Most of your sumps are between 9 and 12 CFM. So this would be a really, really small pump. Most likely a hand pump. I don't think I can think of anything that's that small. You might be able, maybe a fuel pump or something would be that slow. Okay. Let's look at, you go to the store and you see that you've got one item that is priced at $1.20 per pound. Comparable item that is priced at $0.08 per ounce. Which one's more expensive? Well, I'm going to leave this one as dollars per pound, and I'm going to convert this one into dollars per pound. The 0.08 does not need to change. That's already in dollars. I need to get rid of the ounces. Changing them to pounds. 1 pound is 16 ounces. The ounces are gone. 0.08 times 16 is $1.28 per pound. It's $1.28 a pound. So this one is definitely cheaper. Does that make sense? Okay. What if you have something that is rated as 2.4 pounds per cubic inch? In your notes, convert that to tons per cubic foot for me. So here we've got pounds per cubic inch, and we're going to have to change both. I'm usually in the habit of changing the top one first, just because I get into patterns and I stick with them. So pounds are on top, I'm going to put pounds on bottom, and I am changing it to tons. 1 ton is 2,000 pounds. So you can cancel out the pounds. I now have tons per cubic inch. Now I gotta change the cubic inches, so I'm gonna put them on top since they're on bottom. Going into cubic feet, 1 cubic foot, 1,728 cubic inches. So cubic inches are gone. So what we have here, now I'm gonna show you a shortcut. What I've been doing is just multiplying across the top, 2.4 times 1 ton times 1728, getting that answer, then 1 times 2,000 times 1, getting that number, then dividing them out. I can shorten this up a little bit. I start with this number here. And this first fraction is the number on top or bottom. So there's a 1 on top, but the number that's not a 1 is on bottom. Since it's on bottom, that means I'm going to divide by it. 1728 is on top, so I'm going to multiply by that. So 2.4 divided by the 2,000 times 1728. So it's 2.07, 2.074 we'll call it. Tons per cubic foot. It's always amazed me just how close a ton per cubic foot is to being a pound per cubic inch. They're relatively close. Okay. What if I have something listed as being able to pump let's say it's 6,000 gallons per hour. And I want to convert that again to CFM, cubic feet per minute. So 6,000 gallons over 1 hour. In your notes, let's have you try to convert that into cubic feet per minute. So, get rid of the gallons first, going to cubic feet. What's the relationship between gallons and cubic feet? 1 cubic foot is 7.48 gallons. So gallons are gone. What else do we need to change? Hours to minutes. 1 hour is 60 minutes. So hours are gone. So this is going to be 6,000 divided by 7.48 because it's on bottom. And divided by 60 because it's on bottom, giving us 13.37 cubic feet per minute. How many of you got that? Nope, it's on bottom. Hours are on bottom here, so they have to go on top here so they cross cancel.
putting hours into minutes.
Okay. The other thing you could have done is 1 hour is 60 minutes. You could replace the 1 hour 60 minutes. It's still going to be on bottom though. You still have to divide by it. Right from the beginning, you could have said 6,000 gallons per hour. So 6,000 gallons in 60 minutes. But you're still going to be dividing by it. Now that we know some of our metric to standard conversions, let's look at that, what did I say, 30 meters per second. Now, of course, I can convert that to kilometers per hour and all that happy crap. But we're familiar with miles per hour. Let's look at converting it with the metric first. 30 meters per 1 second. Let's convert it into kilometers per hour. So I'm going to have to get rid of the seconds and go to hours. I'm going to do this all in one step. Instead of doing 60 seconds in a minute, 60 minutes in an hour, there's 3,600 seconds in an hour. Seconds are gone. Now I'm going to make this conversion here because when I do my conversions with my metric, I do things a little differently. I don't use that conversion fraction, that unity fraction with my metric. So I've got 3 times 3,600 is 108,000 meters per 1 hour, right? But I don't want meters per hour. I want to put it in kilometers per hour. To get from meters to kilometers, I'm just moving my decimal point 1, 2, 3 spots. It's 108 kilometers per hour. So the question is 108 kilometers per hour fast? Well, we don't really know. Let's convert it into miles per hour. Don't need to change the hours. We just need to change the kilometers. 1 kilometer is approximately 0.6 miles. Come on. Kilometers cross cancel. 108 times 0.6 is what? 64.8 miles per hour. So just a little bit faster than my 90 feet per second, but still probably doable. That one might be stretching it a bit. So here's the thing. Right now on double S out here, the speed limit is 55 miles per hour. If we switch over to metric, what is that going to be in kilometers per hour to keep it equivalent? We'll do 55 miles over 1 hour. Again, we don't need to change the hours. We only need to change the miles. Miles to kilometers. 1 kilometer is about 0.6 miles. So this is going to be 55 divided by 0.6. 91.67 kilometers per hour. They'll probably cheat us out of that a little bit and just round it to 90 kilometers per hour as the speed limit.
Good question.
Yeah.
So in the last one, going from gallons per hour to
Cubic feet. Yep.
per minute. If you had 1 hour, it equals 60 minutes. So say you got 2 hours, you're going to divide that by 60.
Nope. 2 hours you'd multiply by 60.
Multiply by 60. Yeah, that's why. And then, so why wouldn't you multiply that by 60?
Because the hours are on bottom. If they were on top, you'd be multiplying by 60.
Because I don't do that little calculation that you do.
Sure.
I don't write that out.
Yep.
So, okay.
Yeah, if they were on top, you'd have to multiply by 60 from hours to minutes. But when it's on bottom,
Yeah.
You're multiplying the denominator by 60, which divides the answer.
Okay.
If we are strictly in metric units, let's say that we have a medication or fluid or whatever that's concentrated, where you have a concentrate dissolved into a solvent of some sort. And let's say it is dissolved at a rate of 2.3 milligrams per milliliter. And I want to know what's that going to be in kilograms, or sorry, in just grams per liter. Well, since both units are metric, we don't have to do that conversion factor anymore. 2.3 milligrams over 1 milliliter. We're still going to set it up like that. But milligrams have to become grams. To get from milligrams to grams using that chart, how many spots am I moving? Three spots to the left. So I take my decimal point and go 1, 2, 3 spots to the left, putting in the zeros. So that's 0.0023. Milliliters to liters. How many spots am I moving? 3 spots to the left. 1, 2, 3, put in my zeros. That is 0.001. So now to get my final answer, I divide that out. 0.0023 divided by 0.001 is 2.3 grams per liter. Notice there the number doesn't change. Let's say we have an object that has a density listed as 5.1 grams per cubic centimeter. That's saying it's about 5 times as dense as water. I want to know what that's going to be in kilograms per cubic meter. So again, I'm just going to change each of those. Grams have to change into kilograms. To get from grams to kilograms, I'm still moving 3 spots to the left. Putting in zeros makes that 0.0051. Cubic centimeters changing into cubic meters. I have to move how far? 2 spots on the chart, but it's cubed, so I have to move the decimal point 6. So if I divide those out, 0.005 divided by 0.000001, 5,100 kilograms per cubic meter. Somebody want to give me the gas mileage to get in their vehicle? 25, okay. So 25 miles per gallon. We switch over to the metric. How much is that going to be? We'll start out by doing miles per liter, and then we'll go kilometers per liter. 25 miles over 1 gallon. So I want to do miles per liter, so I'm going to put, leaving the miles alone, I'll put gallons on top, liters on bottom. 1 gallon is 3.785 liters. So the gallons are gone. It's 25 divided by 3.785. 6.605 miles per liter. Now if I want to change that from miles per liter to kilometers per liter, miles go on bottom, kilometers on top. 1 kilometer is 0.6 miles. So this is telling me I'm going to have to divide by 0.6. So take my 6.605 divided by 0.6 gives me 11.0, basically 11 kilometers per liter. A little bit of a change, huh? So here's the thing. If we switch to the metric system, anybody want to guess what they would charge per liter for gas? $1 a liter, $1.50 a liter? Probably. Actually, I think in Europe there's spots where they're charging almost $4 a liter. What would be our equivalent price? Right now, how much are you paying per gallon? Is it $2.20, $2.15? $2.19? $2.19 per gallon. Let's look at that as in dollars per liter. $2.19 per 1 gallon. We're going to put gallons on top, liters on bottom. 1 gallon, 3.785 liters. Gallons cancel out. This is going to be 219 divided by 3.785. So if they kept the price the same, it would be 58 cents per liter. We all know they're not going to lower it to that price if we switch. So now, you'd mentioned not using this conversion factor in unity fraction, which is fine, and you do it however you want. But I'm going to show you some other advantages to using this. Do some simple ones for you. For example, let's say we have just your speed listed as 60 miles per hour. You want to know how far can you go in 7 hours? Well, we all know you just take 7 hours times 60 miles per hour, right? Well, why? If we don't know that, how can we figure it out? Well, I want a distance. I'm starting with hours, and I want a distance. So I take my 7 hours, put it over 1, and I can use this as a conversion factor. I can treat this 60 miles per hour as saying 60 miles is equivalent to 1 hour. So when I go to change this, I'm going to put hours on bottom and miles on top. 1 hour is 60 miles. Hours cancel out at 7 times 60 or 420 miles. That was a relatively simple example. What if I ask, still going at 60 miles an hour, how long would it take to go 840 miles? Well, we're starting out with 840 miles here. I'm going to put it over 1. I'm asking how long, so I want to convert miles into hours now. So now I'm going to put miles on bottom and hours on top, so that the miles will cancel out. 1 hour is equivalent to 60 miles.
You always want to make it so they cancel out?
I always want to make it so they cancel out. So now the way this is set up is 840 divided by 60, which is going to be, what, 14 hours? So
No matter what.
Yeah.
You're canceling out.
Yep, you're canceling out the unit. So here, the units tell you what you have to do in the calculation. Again, most of us know you're going to take the distance divided by your speed, and that'll give you how long it's going to take. But what if it's something a little less familiar? Let's say that you have, you're prescribed 80 milligrams of medication, and you look at the label, and it says that it is constituted at, let's say it's at 25 milligrams in 4 milliliters. You need to know how many milliliters of that medication to take. we've got 80 milligrams. We put milligrams on top and converting to milliliters. 25 milligrams and 4 milliliters. So the milligrams cancel out. What we have here is 80 times 4 divided by 25. Gives us 12.8 milliliters of medication. So there's one that we would not have had any clue how to proceed without using the units. Or for you guys, you might have a feed rate. Let's say you have a machine running at, well, let's say it's just running at 400 RPM. I'm going to write RPM out as revolutions over minutes because that's what it stands for. Written like that, it helps us figure this out. And I know that the tool that I have in there, accounting for the number of teeth and everything else and how far it can cut in. Have you guys done cutting speeds and cut times yet? So let's say I know that my tool is capable of advancing 8 thousandths of an inch per revolution. I want to know how many inches per minute. So if I start out with this unit here, it's got minutes on bottom. I want minutes on bottom, so I'm going to keep that the way it is. If I needed minutes on top, I'd flip it over and put 1 minute over 400 revolutions. But in my answer, I'm going to want minutes on bottom, so that'll work. That's 400 revolutions over 1 minute. Now I want to get rid of the revolutions because I want my answer to be inches per minute. So I'm going to put revolutions on bottom here. Well, in this equivalency, think of this again as being 0.008 inches or 8 thousandths of an inch is equivalent to 1 revolution. This would be 0.008 inches per 1 revolution. So the revolutions cancel out. I've got 400 times 0.008, which is going to give me 3.2 inches per minute. Does that make sense? So you guys have a ton of formulas out there for cutting speeds and cutting times and stuff like that, feed rates. You can do it all with the units. By matching up the units, it tells you, do I multiply, do I divide, what do I have to do? Okay. With that, let's do this. Let's say you've got a fuel pump. You're driving down the road, let's say you're doing 80 miles per hour. And your fuel pump is pumping at a rate of 4 gallons per hour. You want to know what is your So I want to find your fuel efficiency in miles per gallon. So I look for what I have here. I want miles on top. So I want to start out with miles on top if I have that somewhere. And I do right here. I have 80 miles per hour. So I'll start with that. Miles are on top. I'm going to keep miles on top, but I want gallons on bottom. So I need to somehow get to gallons on bottom. And I have this relationship here between gallons and hours. So the hours will cancel out, 4 gallons in 1 hour. So the hours cancel out. Here it's going to be 80 miles. Since the 4 is on bottom, I divide by 4. So it's 20 miles, and gallons are on bottom. 20 miles per gallon. So like I said, the units can be a very powerful tool. In your big book, you will find this stuff on page 257, exercise 813A and exercise 8-13B. And on page 258, exercise 8-14. And I am going to give you a new packet. And in this new packet, it's going to be pages 91 through 93. I realize it's a lot of homework on this stuff, but this is actually a very important skill to be able to do, to use the units to make your conversions and calculations. I teach a math for health professionals, for the medical students, for nursing, medical assistants, EMTs, paramedics. 90% of the math they do is looking at the units and using the units to convert the number. You know, if you're prescribed 400 milligrams over the next 8 hours, you've got your medication as concentrated as 5 milligrams per 4 milliliters. Drop factor on your fluid is 12 drops per milliliter. What rate are you going to set that IV in drops per minute and stuff like that? It is all done with those units. So it's a very important skill. So those are the pages out of the book. I'm going to get you the packet here right now.